Good afternoon, everyone. Today we will be discussing semantic search in a community question answering platform for mortgage officers at Zillow. Mortgage is by far one of the most complex financial products. Therefore, a community question answering platform can help the mortgage specialist in a lot of ways. We have built a CQA system for the mortgage officers at Zillow that consists of two major parts. First, a QA platform, and second, a state-of-the-art search engine that allows the user to search public mortgage resources as well as internal contents. The search engine is the subject of this paper. We also have a few requirements for the search engine. We need the top 5 retrieved results to contain as much relevant information as possible. We also want the users to be able to search through natural language queries as well as keywords, and we want the search engine to have low latency. With respect to the available datasets, we have built a mortgage database that contains FAQ answer pairs from well-known mortgage organizations and regulators. The search queries will be searched against this database. We also have an internally annotated dataset that is used for evaluation. This dataset contains queries that are most frequently searched for, and for each of these queries, we have labeled FAQ answer pairs from the mortgage database. Each annotation can have one of these 3 labels: 0 for irrelevant, 1 for somewhat relevant, and 2 for relevant. So based on the observations from our dataset and the requirements, we propose to build a hybrid search engine to retrieve both semantic and lexical information.
As mentioned, we adopted sentence BERT in our model. The BERT module is firstly fine-tuned on the mortgage database through masked language modeling. We then train the BERT model through the Siamese network by following the SBERT paper. By doing so, we believe the SBERT model is able to generate sentence embeddings adapted to the mortgage domain. The indexing process involves 3 methods. SBERT is used to generate embeddings for just the FAQ title, and we also use TF-IDF and BM25 to generate indices for both the FAQ title and the answer. The retrieving process consists of 2 steps. The initial ranking score is computed by the first equation. It is a weighted average of SBERT and TF-IDF similarity. Equation 2 shows how we calculate the cosine similarity score for SBERT and TF-IDF. For TF-IDF, another weight is set to merge the score of the FAQ title and the score of the answer. Equation 3 is a dampening factor. In short, it favors TF-IDF score over SBERT when queries are longer. We also compute the BM25 score. The weight between the title and the answer is the same as the one in TF-IDF. The final ranking is produced by a reciprocal rank fusion between the initial ranking and the BM25 ranking. The K in the equation is a hyperparameter. This is the overall architecture. The top part is the indexing process, and the bottom part is the retrieving process. As mentioned, when the query comes, it firstly combines the score from SBERT and TF-IDF, and then BM25 is used to help produce the final ranking.
We use a standard IR metrics to evaluate the search engine. Our results indicate that inclusion of SBERT either with TF-IDF or with TF-IDF and BM25 improves the ranking for the top 5 retrieved results. But BM25 will catch up the ranking is extended beyond the top 5. The reason is that SBERT is great when there is a strong semantic signal between the query and the FAQ part, and therefore the top 5 results retrieved with SBERT are more relevant, but can bring in some noise for less relevant results, mainly because it does not have visibility to the answer part, which usually has more information. Whereas BM25 is using the information in both the question and answer parts. So we believe that if we extend SBERT to the answer part as well, the entire final ranking will be better than BM25. Also, the bottom table shows the cases where there have been minimal lexical overlaps between the query and the FAQ answer pair, but SBERT was able to retrieve. So for future work, we intend to extend SBERT encoding to answer as well. We also plan to use the QA platform signals for a more efficient retrieval. And with collecting feedback from our users, we can adopt LTR approaches. Also on the data side, we want to explore weakly supervised approaches to create label data to further fine-tune SBERT on mortgage-specific data. And we also plan to explore the unsupervised sentence and document embeddings.